Hello, everyone. Thank you for joining this webinar. My name is Anca Turtoi, and I'm a Romanian living and working in the Netherlands. So it feels great to participate to this conference and see the local interest for this topic. Nevertheless, I will be presenting in English for any non-Romanian speaker that may join this session. So I'm part of the Holland Circular Hotspot team. I work as an operations manager, and I will share today with you some interesting Dutch showcases in the water sector. Just to clarify ahead, I am not a water expert, so please be mild with the technical questions afterwards. What is Holland Circular Hotspot? Well, Holland Circular Hotspot is a private-public platform in which companies, knowledge institutes, and local governments collaborate internationally with the aim of exchanging knowledge and stimulating entrepreneurship in the field of circular economy. The organization focuses on developing an online community for international parties so that challenges and circular solutions become visible and the business potential can be exploited. In line with this, the Holland Circular Hotspot assists foreign parties in finding Dutch businesses as partners on circular economy topic, and also facilitates the access of the business community to Dutch and international instruments and programs. Jumping to our theme of today, water, I would first want to start with few worrying facts about water in today's society. Like, for example, having more than 80% of wastewater resulting from human activities being discharged in rivers and sea without any pollution removal. And while over 2 billion people live in countries experiencing high water stress, on the other side, 3 in 10 people in other places lack access to safely managed drinking water services. So, nevertheless, circular strategies are increasingly showcasing the potential to ease the complex relationship between society and water throughout the world. But first, let's take a quick look at what circular economy is. This one here in the picture we call the value hill. And you can see a comparison between the most dominant economy nowadays, the linear economy on the left, and the circular economy on the right. All over the world, we have developed sophisticated ways to design, to produce, distribute, and sell goods by extracting resources from the earth, refining them for manufacturing, assembling into products, and distributing them to the consumer. Value is constantly added at every step, but after the consumer uses the product, however, in the linear economy, its value goes downhill, so more often ending in the trash. In a circular economy, businesses aim to retain a product added value for as long as possible, so keeping resources in use. In the context of this value hill, value is added while the product moves uphill, and circular strategies keep the product at its highest value for as long as possible. This figure, which I don't have, unfortunately, that much time to detail, shows the 3 principles of circular economy, their corresponding strategies, looking at the colors of the arrows, and to which step of the value chain they can be applied. I will leave this for you for the after read when you get the presentation, if you're interested to check out more. As you maybe know, there have been reports showing the applicability of circular economy for addressing most of the Sustainable Development Goals. In the case of SDG 6, the main aim is to ensure the availability and sustainable management of water and sanitation for all. This figure here illustrates the identified connections between water, water ecosystems, and circular economy, and can be a good framework to provide the basis for initiating and developing national or regional dialogues around the water utility pathways in circular economy, of course, taking into consideration the importance of local context. As you see in the figure also, the strategies from the value hill can also be found: recovery, reduce, reuse, recycle, for example. Well, here is why Dutch examples are relevant examples to take into consideration for the water sector. For instance, Netherlands is one of the most densely populated countries of European Union, with 30% of the country being below sea level. And it's also the delta of three main European rivers. These rivers have passed through cities, industrial, agricultural areas before flowing into the Netherlands. So clean water becomes a challenge. And this is also the reason why water treatment became such an essential part of the country's DNA. Also, having limited space and limited natural resources, it makes sense to find local and scalable solutions to close the resource cycles. That's why regional water authorities in the Netherlands no longer regard their wastewater as a waste product to be treated and processed, but also as a source of sustainable energy, raw materials, and clean water. So let's now jump into some Dutch examples. One of those materials that can come out of the wastewater is bioplastic. Bioplastic produced by bacteria from wastewater, which is the polyhydroxyalkanoate, or for short, PHA. The secret of this bioplastic lies in the sludge, translated as namol, which is created in abundance at a sewage treatment plant. In the past, sludge was a residual product that went to waste incineration, and it's now a raw material. PHA has excellent proven technical properties and is biodegradable under certain conditions. And while plastic breaks in 100 years, traditional plastic, the bioplastic takes less than a year under normal circumstances. Fario's research started in 2014, and the next year they had the first kilo of PHA. The result of their pilot study showed that it's a very good quality plastic that can be produced for a competitive market price. Moreover, the production process is more sustainable than the available alternatives, as some other bioplastics are made from sugar or palm oil, which compete with the food chain, or the traditional plastic that comes out of oil production, which pollutes intensively. It's very important to know that Fario is carried out by a consortium consisting of 5 regional water boards, energy and raw material factory, sewage water sludge burners, and also technology developers like Technical University of Delft. Because why I'm saying this is because collaboration is key for success in circular economy. And you will see that also in the upcoming examples. An example of raw material recovery comes from phosphaceae. Phosphate is an expensive and scarce fertilizer that the Netherlands imported in the form of mined phosphate ore and biomass. The phosphate can enter the consumer via the food chain. Therefore, afterwards, phosphate is lost via the sewer, which makes the cycle incomplete. Since 2013, Waternet, the responsible water management company in and around Amsterdam, has been recovering phosphate from household wastewater in the form of struvite. But from 2016, in order to recover a higher percentage of phosphate and at a lower logistical cost, they started using pure urine from the urinals of music venues and other large events. Then, at the sewage treatment plant, the phosphate is biologically removed from the wastewater, and during fermentation, also biogas is produced. The biogas is then used as a supply for energy, and the phosphate is recovered as a fertilizer that can be either used locally in the Netherlands or for international trade. This struvite installation called Phosphace produces around 1,000 tons of struvite per year. Going to the next slide. We have a water and energy example related to sewer water. The average temperature of the sewer water is around 18 degrees. And with this Hydrea turnpipe designed by Heijmans, the warmth of the sewage water can be reused. The sewage pipe collects and transports the wastewater, as well as extracting heat from it at the same time. One pipe of 150 meters can provide sufficient heat to 100 homes, which is an entire neighborhood in the Netherlands. Moreover, this way fossil fuels such as gas for heating households can be saved, getting us closer to energy neutral goal. This system consists of a concrete sewer pipe of 1.6 meter wide, a plastic spiral winding pipe built into the inner shell, which acts as a heat exchanger, and through which water flows. Clean water flows in the pipe, in the plastic spiral. So the heat exchangers then transfer the heat to the clean water to the place where the pipe goes and where the heat is needed to be used. It is extremely suitable for housing corporations, municipalities, water boards, drinking water company, but also companies that may discharge a lot of residual heat through the sewer. And it is sustainable in 3 ways. It saves money, even for household. It's around 200 euros per year with heating. It saves raw materials and CO2. And the integration of the pipelines also can save expensive excavation work and urban space because it acts as a 2-in-1 solution. On top of that, the material is indestructible and it's resistant to contamination, and it can last around almost up till 100 years. So this is again an example of 3 parties' close collaboration, combining the field of expertise of Heijmans, which is a developer, builder, and energy specialist, with the Belgian company Socea as a producer of concrete pipes, and a German company, Frank, which is a supplier of high-quality plastic products. Moving to the next example, we have Wittens, and Wittens supplies clean drinking water to around 6 million Dutch people in the Netherlands. The company primarily uses groundwater extracted from water collection areas, and some of these collection areas are situated in agricultural land, which sometimes contains nitrates and pesticides, making the water generally more difficult to purify. But Wittens has developed a method to retain the food producing capabilities of the land while still producing clean drinking water extracted from under farmland. In the process, about 60,000 tons of byproducts, such as calcium, iron, and humic substances are released. And back in 2012, Vitens set itself the goal of using these residual flows as valuable raw materials. And together with parties like the Wageningen University, an innovative process was developed to separate the byproducts and use them as soil improvers. So this new way of working has turned the investment cost of 1.8 million euros per year into a source of income, enabling the development of new innovations. And now that Vitens can produce natural soil improvers, such as humic substances or chalk pellets, it's also able to cooperate productively with the farmers in the same catchment area where they take the water from. So it's a win-win situation for both parties, resulting in healthy soil, better crop yields, and high-quality drinking water. A waste reduction example and another raw material saving comes from zero brine. But maybe it's good to first look at the predecessor of zero brine, which was sole brine. By the way, brine is salty water, so water strongly impregnated with salt, in this case from industrial wastewater. In 2015, Sol Brine and the National Technical University in Athens was selected as the best project implemented over the last 25 years in the category of environment by the EU Commission. The Sol Brine project developed an energy autonomous, powered by solar energy autonomous brine treatment for the total elimination of the brine. It was firstly installed at a desalination plant in Greece, in the Cyclades Islands, and it separated the brine into two useful byproducts, which is dry salt and water. The water was reused in the process, while the salt was being sold for industrial purposes. The project was aiming at eliminating the current practice of brine disposal, and by the results of the scheme caused a transition into the commercial sector, and it's now managed by a Dutch company who is the originator of Zero Brine, a project even more ambitious and complex than Sol Brine, which has 22 partners, 10 countries, 4 years. It's still an ongoing project from 2017 to 2021, coordinated by Technical University of Delft and funded by Horizon 2020 program. Zero Brine is an innovation action project that aims to recover even more valuable byproducts from industrial wastewater, such as magnesium, salts, and clean water, to reuse these resources in other processes, thus closing the loop and contributing to circular economy. For this, Zero Brine includes 4 pilot projects for treating salty wastewater around Europe. It has water treatment, so it works together with the water treatment plant in the Netherlands, using nanofiltration and ion exchange. It works with a coal mine in Poland using reverse osmosis and electrodialysis. A chemical factory in Spain using recovered membranes from desalination plants and advanced crystallization techniques. And the textile factory in Turkey using oxidation and ion exchange. So it tries to touch upon more industries. Recovering water and raw materials to reuse in other industry, Zero Brine is, as I mentioned, advancing circular economy solutions for Europe. Moving to a repurpose example about efficient use of land and subsoil, we have the very nice water square from Rotterdam, which is said to be the world's first full-scale water square, which has a multifunctional design, making water storage facilities both visible but still enjoyable. As you maybe know, cities in the Netherlands are densely built and need to cope with intense rainfall and increasing risk of floods. So to respond to these challenges in a truly sustainable manner, students, citizens, urban planners, and architects co-created the Rotterdam Water Square. It's a square that improves the livability and spatial quality in the city when it's dry, and it retains water during rainfall. So during normal weather conditions, the square offers nice spots for sport and recreation. It has amphitheaters, basketball, volleyball courts. But however, due to its multifunctional and intelligent design, the square's 4 basins retain water from the square and surrounding rooftops during heavy rainfall. So this water is retained in these low areas, keeping it away from the sewage system and preventing urban floods at the time when the city's canal system has enough capacity to allow the runoff of the stored water to the nearest open water. Then the stored water slowly disappears to make room for various users again. This way, the initiative enabled ordinary citizens to commonly develop a climate-proof square that safeguards the livability in the city in all respects. You can see on the right side how it acts in different seasons or at the different levels of rain. Quickly to my last case. In the more busier and more densely urban environment, rooftops are no longer just the top of the building, but become an integral, functional part of the building's energy performance, its rainwater management, while also reducing the urban heat effect with a positive impact on people, human health, and biodiversity. More and more rooftops have been transformed to green oases in the heart of Amsterdam, and many different species of plants grow in these blue and green roof systems. Here is a picture of how it actually works. It's pretty easy. The smart roof acts as a water collector. Mainly water is captured, stored, and then capillarily fed back to the soil for plant irrigation without needing any use of pumps, hoses, or energy. And then it also adds more green to the city, capturing more CO2 and allowing to grow your gardens locally and on your building, not only on farms and in villages. So making food more easy to get. To close, I think the most important things that you should take away from these presentations are that water is about lives, it's about safety and food, and people have a direct connection with it. Therefore, it becomes a higher priority on the list, more than, let's say, waste management, which you can maybe just dump outside town and see the effects in 10 years. Not that I'm undermining waste management, but this really makes water political and actionable. Politicians can score points with it because it's so close to us. And circular economy examples makes a lot of sense when there are great risks, scarcity, and dependencies with water. So I know some solutions that I showed are, however, costly. For example, the Struvite recovery, but they are really strategic And it would mean, for example, no phosphate mines in Europe for fertilizer production. Some solutions have high upfront cost, like energy recovery from sewer, but some are even lower in costs and are relatively easy to implement. So, and you always see that collaboration is really the key, and it's needed to thrive in the circular economy and in the new world that we live in. So thank you for your time, and I hope this case is inspired you a bit. Now I can take some questions. I don't hear anyone, by the way.
Okay.
Yes.
There is a question. Do you have any idea, a figure of how much of used waste is still a real waste in any of the examples presented?
Tough question. So how much of the real waste?
How much of the used waste is still a real waste?
Yeah, I don't really know any facts, any figures related to this question. And it's also a bit vague, I think. So
I believe it refers to the waste that is not recovered, maybe.
okay, so definitely there is in all of this process there will be a part of waste, but I think in most of the examples it's looking at the majority and the waste that it really polluted or it can be really valued. So it's not as much as fully eliminating all the waste in the process, but eliminating the majority of it and the one that can affect the environment or that can actually bring us something more and that we don't throw a valuable, let's say.
Okay, thank you very much. Thank you for the presentation. And we learn a lot of interesting facts from it. We hope that you'll be present for the other webinars as an attendee. Thank you.
I will try. Thank you. Thank you. Have a great
Bye.
day. Bye bye.
You too. Bye bye.